Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Phase transfer catalysis, PTC. The reaction involves converting a primary alkyl bromide, 1-bromodecane, CH3, CH2, 8CH2Br, to a nitrile, CH3, CH2, 8CH2CN, using KCN in benzene. The challenge here is that KCN is an ionic salt, water-soluble, polar, while the alkyl bromide and benzene are nonpolar organic. This creates a two-phase problem. The nucleophile, CN-, resides in the aqueous ionic phase and cannot easily react with the substrate in the organic phase. Moving on to the next step. For such reactions, a phase transfer catalyst, PTC, is required. A PTC shuttles anions, like CN-, from the ionic phase into the organic phase, enabling the SN2 reaction to proceed efficiently. Moving on to the next step. A phase transfer catalyst is typically a quaternary ammonium salt. It has a positively charged nitrogen center that can associate with the CN anion and a lipophilic, organic-soluble, organic framework that allows it to carry the ion pair into the organic, benzene, phase. And for the final step. A. Benzyl chloride, PHCH2Cl. This is an alkyl halide, not a quaternary ammonium salt. It cannot act as a PTC. It might alkylate CN but is not a catalyst. B. Aniline, PHNH2. This is a primary amine, not a quaternary ammonium salt. It lacks the permanent positive charge needed to shuttle anions. Not a PTC. C. Benzyl trimethylammonium chloride, PHCH2N+, CH3, 3Cl. This is a quaternary ammonium salt with a permanent positive charge. The lipophilic benzyl and methyl groups allow it to partition into the organic phase, carrying CN along with it, enabling the SN2 reaction in benzene. This is a classic phase transfer catalyst. D. Acetanilide, PHNHCOCH3. This is an amide, not a quaternary ammonium salt. It has no permanent positive charge and cannot function as a PTC. Option C. Benzyl trimethylammonium chloride is a quaternary ammonium salt and functions as a phase transfer catalyst by transferring CN from the ionic environment into the organic benzene phase, dramatically accelerating the SN2 reaction. Therefore, the correct answer is C. Therefore, the correct answer is option C.